Hi, everybody. This is Joanne with Read Science, Science Goddess on Twitter. And of course, I am here with my co-host, Jeff Schomeyer, sitting in Maryland. And today we are joined by our first guest who puts the M in STEM, mathematician, Richard Evan Schwartz. I see you make sure to delineate yourself from other Richard Schwartzes on the internet. And so he joins us from Brown University in Rhode Island. And he has written some books that I was surprisingly excited about. So he is a mathematician notable for his contributions to geometric group theory, and in his spare time draws comic books. And I understand that when your daughters were young, you were teaching them about math, and you drew some pictures for them, which became a poster, which became a book. And in a way, the rest is almost history. I believe you have other books besides these graphical books, but one of the most popular best-selling books, I picked it up from the library. Thank you, library. You Can Count on Monsters is really pretty amazing. I look forward to talking about how you came up with these graphical representations to make multiplication intuitive and prime numbers and things like this. And then I also read in the beginning of this book that when kids find out you're a mathematician, they want to know a really big number. And I guess this book says, here's some really big numbers. Right. And again, amazing graphical illustrations, self-portraits, I believe, in addition to your daughters and things like that. And the most recent book that we were sent is something called Gallery of the Infinite, where you explain infinity and the fact that actually there's more than one size to infinity, which actually sort of scares me. So welcome, Richard. We look forward to having a great conversation.
Thanks. It's a pleasure to be on.
Be calm, Joanne. All will be fine. These are some of my favorite topics. We're going to be talking today a lot about infinity and different sizes of infinity. And I still love those ideas so much. It's clear that you do too, but I was thinking when I started reading, it's been a long time since my own exposure to any ideas about infinity from when I was in college, which is now several centuries ago. And I don't really remember my reactions like to learning calculus or to discovering or being taught that there are different sizes and ordering to infinity. How do people react when you tell them, when they find out that there are different sizes of infinity?
Yeah, you get kind of mixed reactions. I mean, some people, there's a baseline where people are very afraid of math, and so they don't want to, they don't want to hear it. It's sort of like, back off. I mean,
yes, vulture, vampire things or something.
There's to explain what it means, it takes a certain amount of getting into just what do different sizes mean. So a lot of times, if they're science-minded scientists, they may say, well, what do you mean, and ask for an explanation. I'd say that high school and college students, I'd say, give the biggest reaction, where it's really kind of a revelation.
Maybe they know enough to be surprised, but not quite enough.
It's like they're kind of willing to listen. You're at the age where you're learning lots of different ideas, and then here's this kind of really radical thing that you don't see in your high school classes, let's say.
And yet you find today most people use the word infinity. They have an idea, and it seems perhaps. I think your book does a super job with rather few words and these fun pictures that we're getting into. That it doesn't take much to draw them into understanding natural numbers, and then the bigger numbers, and comparing things. And where did I write down? You write, we have to have, I think, one technical term will be bijection.
Yeah, that's right.
That will come up.
Yeah, I could have even, I could have even just said matching. I think,
I don't think a little vocabulary hurts, and you're going to use it.
Mhm.
And there's this. I quoted you: finding a bijection between two finite sets, a way to match the
Right.
sets up, is a way of saying that they have the same size. And I wrote down, this is such an instant, obvious idea,
Right.
because you introduce it, and we're looking at playing cards and weird monsters, and we go, yeah, sure. Look, there are 4 of them over here, and there are 4 of them over here, and you can say those go with those, so they've got the same size. And seems to me almost like you sucker people into accepting.
Yeah, that's right. You could explain. That's right. It's a funny, a lot of math is like that, but especially this kind of math where it leads you on kind of step by step. That's what I love about math. It's like, well, you'll accept this, right? Yep, I'll accept that. Well, and now this, and every individual step is sort of, pedestrian, and then you're at this kind of mind-blowing conclusion where, well, okay, this is just what you get from the logic.
It seems so easy. And suddenly you've got an infinite number of sizes of infinity, and what does that even mean?
Right. But I wanted to do that to just bring them. Mathematicians or math students are certainly used to this. So all our classes are like that. Like, you're first given this little definition and this lemma, and it just kind of moves along, and then it rolls towards some kind of amazing conclusion. So I wanted to do that in a book. Very, very gently, just bring people along to this kind of astonishing, kind of astonishing conclusion in a way.
Right. Any individual page is not that hard to accept and digest.
Right, that's right. You say, okay, all right, right. You almost get lulled into a feeling of, complacency or something, or like, okay, and then what?
As you wrote early on, a mathematical view of infinity leads to some breathtaking surprises.
Right, that's right.
And that's really what happens here. And it doesn't take much. My other favorite little moment of like, yeah, sure, and then boom, was you said, well, a set is called infinite if it's not finite. And I thought, really, I'm not sure that's the definition we expected of what an infinite set is. It's like, here are all these finite sets over here, and those over there don't fit. Those are the infinite ones.
Right. It's a little, yeah, right. It kind of sneaks up. It's a little bit mundane almost. Like what's the big deal?
It covers everything. It's very operational, right?
That's right. I mean, there's a lot of, one thing, another thing I wanted to do was, talk about, there's a lot about infinity in the, in the popular culture. I mean, people have been interested in the infinite probably for as long as there have been people, I'd say. It comes up in, theology. I don't know. There's many subjects in art and literature where people talk about the infinite. And, what I like about the mathematical view is it's kind of clean and simple, and it tries to say exactly what it is. So I wanted to give this, in a way, a kind of a plain spoken view of what it is.
Yeah, I want to see what Joanne's reaction was, but I thought maybe just to have some more background here, can you tell us a bit about Georg Cantor and how it is that this idea of infinities as a problem to be handled even came along? This is not your thing, but
right. Well, it's I mean, I'm not. It's not clear. I'm not sure exactly. I mean, it can't. People, when you learn about it in school, they say Cantor was thinking about these weird functions on the line. Like when you're in school, you might learn about the function like f of x equals, x squared or something, and then you might graph it. You'll get a parabola. And Cantor was interested in kind of much wilder kinds of functions that were very, very jagged. And maybe at some places they go and then they jump, and then there are other places where they kind of go and then they make a jump, and then they go and they make a jump. And you could imagine, well, maybe it kind of makes jumps all over the place. Like, could that happen? Could you have a function that sort of, I think also there was the interest in looking at these really jagged functions maybe came from physics, actually, where where people were thinking about Fourier series and waves. So you have like there's like a principle of superposition where this is for people who aren't physicists, unlike you, where you have lots and lots of waves of different frequencies, and you kind of superimpose them to get a more complicated looking sound. And you could imagine that, like, the question is, like, if you have an infinite number of waves of different frequencies and you put all these things together, I mean, what do you get? And so you might get things that, you know, where it was the high frequency stuff might be so complicated or so prevalent that, you know, what you get in the end has lots of little jumps. And I think Cantor, you know, his subject was really analysis, and he wanted to understand the sets of points where these jumps could occur. And eventually he got the idea that, well, maybe there's like a different order of infinity that if you kind of, you know, if you want to talk about sets of points on the line, then suddenly, well, you're talking about this thing called sets. And he discovered, well, yeah, actually, you know, you could have more than one size. So I think that the original motivation came from this kind of analysis of functions, and particularly of, you know, Fourier series, and then it kind of took on a life of its own. And I don't, you know, he just started, you know, he kind of invented this whole idea of you know, sets, and it was the beginning of, you know, this kind of modern idea of set theory.
The romantic notion among mathematicians, I think, is that, and this is what drove him crazy, which is no surprise at all.
Yeah, right. He did go crazy, and, you know, and then there's lots of problems with it. I mean, I think that, you know, he had this idea, and then, you know, people like Bertrand Russell later came along, and they actually, there's this great Logic Comics, this comic book, which some of your listeners may have seen. But anyway, there's this, you know, discussion of, like, what are the foundations of mathematics and what really are sets. And so after Cantor, people, you know, in a way, people are still debating this. You know, Cantor kind of introduced this all at once, and then since then, people have been kind of writing in the fine print, you might say.
But you're one of the ones who sees sets as sort of like the most basic place to start. Maybe it's not the only one.
I mean, I think, you know, math has this funny thing. When you first learn about it, you think, yeah, it's rock solid. Like, you know, someone asks, like, you know, it's not, you know, other subjects, you know, other sciences are more in flux, like economics, let's say. You know, where you know, there are certain things that people think might be true, and, you know, there's hypotheses, and they might later be disproved. But you think, like, math, no, that's not like that. I mean, it's just completely solid, right from the bottom. And in a sense, it's true, although it doesn't quite start from nothing. Like, you know, there is, for example, a notion of a set, which is what, you know, a set's a collection of things. And then you might say, well, what are things? Well, they're kind of, you know, gizmos, they're gadgets, you know, you know what they are, they're stuff. But then you could ask, like, what's a gizmo, what's stuff, what's a gadget? And in the end, there has to be this kind of undefined thing, like, what's a set? And then it's not good enough just to say what a set is. You have to start talking about what you can do with sets. Like, for example, if you have two sets, you could kind of combine them into a larger set, and things like that. Or you can take two sets. And so at the bottom of mathematics, at least currently, you know, in the 21st century, is that there's this kind of list of axioms where you have these few undefined notions, and also, you might say, unprovable or unproved assertions about how they behave. And then after that, they're all it's all rock solid after that, somehow. Like, you know, I would say, like, I'm sort of a work-a-day kind of mathematician, where, you know, I'm thinking about, as you said, like geometry or group theory or other subjects where we're not questioning these foundations somehow. It's more like there's a division of labor in math, and you know,
and not everyone is doing all of the foundation and things all the time.
That's right. So for, you know, so my personal point of view is, like, yeah, I think the foundations are, you know, pretty solid. They're as good as anything, you know. I would say mathematics is as solid as anything else that humans do.
Yeah. So what did you think about different sizes of infinity, Joanne?
Oh, well, it utterly terrified me. But I mean, I did appreciate the way the book was going slowly. So sad to say, as a biologist, you know, my speed really were these books. You know, but I was enchanted by these books. So I know, Jeff, you didn't have a chance to.
No, I haven't read them yet, but I'm going to look for them.
So what I'd like to do is, for the sake of our viewers, is to sort of have Richard sort of step back and sort of start talking about these books because they preceded this one.
Yeah, that's true. I mean, I did, I wrote the Gallery of the Infinite in a sense as a sequel to the Really Big Numbers book. And in fact, on the last...
That makes sense.
Yeah, I mean, the last page of the Really Big Numbers book says that, well, infinity is farther away than you thought. And so then I got the idea, like, even at the time I was writing the Big Numbers book, I remember thinking, like, well, I could add another chapter to the Big Numbers book where I did talk about, but then I thought, well, probably I've said enough.
There's a lot in here.
And move on. So okay, yeah. So what shall I talk about, the prime numbers first? I mean,
the monsters.
Monster books? I mean,
yeah, let's start with the monster book.
So okay, well, so I'm not, I always like to draw, I guess, and usually it was just kind of stick figures or very, very simple. I would do them by hand. And at the same time, well, for this book, I originally what I did originally was I think it was my daughter Lucy's 5th birthday, and I wanted to teach her about prime and composite numbers. So my first idea was I just wrote a bunch of smiley faces, like 2, 3, 4, well, faces, and then the primes were smiling and the composite numbers were frowning, and I wanted her to see if she could, guess what that was. And then I thought, well, maybe I'll jazz this up a little bit and I'll start making a different kind of monster for each prime and each number. And at some point it was out of laziness that I hit on this good idea, where originally I was making a new monster for every number. So this was kind of taking a lot of creative effort to get into the 20s and 30s. And at some point I got the idea, well, really I just need to make monsters for the prime numbers, because if I have a composite number like 6, which is 2 times 3, I could, instead of drawing a 6 monster, I can draw a 2 monster and a 3 monster.
Right.
So I started doing that, and then I at some point I switched to the computer to draw the pictures. So math, I don't know about biologists and physicists, but mathematicians often use this program called Xfig, which is just a program that will let you, will illustrate, you can make diagrams, straight line drawings for your papers. So I've been using this thing for years to illustrate my articles, and then I noticed at some point, oh, actually you can, color in the line diagrams, and so I started, using Xfig to draw these monsters.
Wow.
So this program, some people, there's Mac Paint is something that people might be familiar with, or Google Draw. Mm-hmm. These are programs where you can draw straight lines and polygons and circles, and you can fill them in, and so all these pictures are really based on these simple geometric shapes, which I love. Maybe that's my favorite thing in the world, is kind of geometric shapes. So I made these kind of simple pictures, and gradually they got more sophisticated, and I think after about 4 or 5 years, I managed to get up to 100.
Okay.
So I had this poster, which I loved, and I didn't know what to do with it. At some point, I thought maybe I would try to sell this thing or market it, but it didn't seem like there's really a lot of scope for that. So then, meanwhile, I was sort of making these comic books, also using the computer, which, with titles like Man versus Dog, which were never going to, probably never going to get published. And I was just I had been using these self-publishing venues like CreateSpace, where you just send in a file and they publish on demand. But then my wife said, well, why don't you try publishing this? So, cut the poster up into a book, just put a cover on it, and and so I sent it. I sent it to Alice and Klaus Peters. I guess Klaus is no longer live, but they have a publishing house called A.K. Peters, and they publish a lot of really amazing math books. And anyway, they wrote back within 20 minutes and said, "We'll take it."
Wow, that was a good move.
So it was a good move.
Wife is a genius. That was a good move for the publisher.
So this was really great. So so it got, so then I added some things to it, like an introduction and a sort of maybe some appendices in the back where I described some more math. And this went on for a few years, and I can't remember why I wanted to write. I mean, the really big numbers book. So anyway, this book is for kids like age maybe 6 to 8 or 10, and
right. Well, my 21-year-old daughter and I were the ones just like going, oh my, just like.
Yeah, no, that's right. Sometimes it's
we're like,
so
we're like looking, because we're like 29. Wonder if there's 29 on this thing, and we sat there and actually counted,
Right.
and we kept looking in the pictures like, where is this number? And of course we were looking for the elements of the previous numbers.
Right, that's right. I wanted to give the numbers personalities, and so when they would interact with each other, they would. Right, this is somehow the 3 monster kind of wrapped around the 11 monster.
Right. So everything. So it's just one of those things.
I guess the 50. Yeah, Open to 56 is the one I like. That's the one that's the one I spent the most time on by like a factor of 5.
Okay, let's take a look here. 56. Aha. Oh my goodness.
Yeah, so this one, these 2 monsters, they're really kind of haranguing the 7.
The two are the googly eye monster.
2 are the googly eye thing. So there's 3 of them, and they're all kind of linked with this 7 monster, and it's not a happy scene, I'd say. But so anyway, I had all kinds of crazy ideas about the book. I thought, like, if I had more ability, I would write an opera where it would be a succession of scenes, and in each scene, like in the 6th scene, the 2 character and the 3 character would sing a duet, and then and so the scenes would all be tied to the characters would come in according to the numbers. And I had all kinds of, I thought about writing a trial that worked this way, where all there'd be like a 5 lawyer and a 7 defendant and so on. And but none of this came to pass. So but
I'm writing down the title, A Really Big Opera, because I think that's got legs.
We might have opera. That's right. I mean, anyway, it was an idea that the whole structure would be kind of forced by the structure of the natural numbers. But anyway, I tried to do this in the book, make it somewhat, like not exactly a story, but at least give the numbers personalities, and when they would interact, and somehow some of them didn't like each other, others liked each other.
Yeah, we have some smiles and some frowns and some,
Yeah, that's right. That's another. So anyway, and I loved making those pictures, and maybe I thought about doing I thought for a while maybe I would make a sequel to this book where I would, a lot of people ask me about this, like, well, why do you stop at 100? And one idea I had, which never was, I would pick some really big numbers, like 2 to the 10th power or something. Or interesting big numbers, and factor them and make these big kinds of collages. But I never did that. I decided to move on, and I guess write really the really big numbers.
Right. Right. So actually, for both of these books, but just quickly on this one, do you get feedback letters from parents of kids or teachers of kids who are very visual, and like they attribute your book to helping them learn?
Yeah,
so like times table.
Yeah, I mean, I'd say I get few but extremely enthusiastic letters. So one teacher wrote to me, and she said she plastered the wall of her classroom with it, and with another. I mean, some people they've done art projects in their class where they have their kids make their own versions, and I think that's my favorite thing, because I could easily imagine other kinds of pictures and other styles, and I think it's a really good idea to factor things this way. And so, so I've had people say, yeah, I'm doing this as an art project, and there's just some number of kids who are just really, really into math.
Right.
Like I was that kind of kid as well. And in a way, I wrote these books because I wanted something that I would, maybe a lot of authors would say that I wanted something that I would have enjoyed at that age. And so I will occasionally get these like extremely enthusiastic letters from either parents or kids where they love the book, they read it every night, and that
I could see that happening. You could totally see that.
the most interesting. I got a really interesting letter from the parent of an autistic child, and they were who loved the book, and they were speculating that what the child liked about it was that it was this combination of sort of order and whimsy. Like, there's a lot of kind of flashing things going on, but there's this kind of rigid underlying order that in a way is calming. I mean, in a way,
yes.
All of mathematics is like that. I like it for that reason. It's very, in a sense, it's calming. It's extremely predictable. Once you're, I mean, it's also, I mean, it's unpredictable too. I don't want to, I mean, often there are these brilliant insights that come out of the blue, but in terms of the reading of mathematics, it kind of, at its best, it's like very methodical. It's orderly and and.
You know what? I will tell you what my daughter said. My daughter is a physics major. She's working on her PhD. And she said something that you would never hear coming from my mouth is, oh, I love when I have 6-page math problems or whatever. She says, because when you get to the end and the answer is wrong, something's not right. She goes, what is wrong is in those pages. And I went, I never thought of it that way. Like, that's very comforting. Like, it's not as chaotic as the world. It's still constrained within these 6 pages.
Right, that's right. That's right. There's a kind of a procedure to find where the mistake might be.
Yeah, yeah. So I was like, okay, I would never have said that. I would have sat at the end of my half-page problem and went, it's wrong. What did I do wrong? But she finds it actually comforting. So
yeah,
it's like,
it's an insight into personality differences.
Yeah, I think that's right. A lot of yeah, I mean, I like that too. The fact that you can kind of get to even if it looks like a mess, you can get to the bottom of it.
But your books are going to be a find for some people because mathematics is probably not the first thing they think about as fun and whimsical.
Yeah. Oh no, that's true. I mean, it's but I think as I mean, you guys probably know as scientists that from the outside, science might look kind of cold and calculating and. I mean, that's part of science, of course, calculations. But, it's also this kind of, in a way, it's very emotional and it's exciting. And, it doesn't, if you look at the day-to-day life of a scientist, it's filled with exciting things. And, you might just bolt awake in the middle of the night and think, oh my God.
But indeed, not everything is exciting. But for our purposes on this show, too, not only are the books whimsical and entertaining and fun, they're also not incorrect.
Right. Right. Yeah, that's right. That's a good. Yeah, right. That's right.
One of the biggest things we judge on, one of the biggest things I judge on, it's like if we can do this without being misleading or saying anything wrong, that worked for me for Gallery of the Infinite. It's like these are pretty incredible ideas, and I thought it was very telling when Joanne said, "Oh, I like that you went slowly enough." It's like. Joanne thought you were proceeding slowly and carefully, which is quite a thing, because it seemed to me like we were just blowing through it, and it was a lot of fun with new insights.
I didn't have to turn the page if I didn't want to.
Right. Yeah, that's right. I mean, that math can be off-putting. Math. One thing about math can be off-putting is that it's very compressed.
Yes.
You want to sort of get to the frontiers of research, say, as a mathematician, and so you don't necessarily kind of really you think of the most efficient way to think about all the things and but then the writing of mathematics also it's almost like you read a page and it's like, oh wow, I'd have to spend 3 more years in grad school just to get through this page, and so it puts people off. It's almost like it's the wrong frequency. It's too shrill. So I wanted to slow it down. Just take this Gallery of the Infinite might be the first 15 or 20 pages of a book on set theory. And so I wanted to just slow it down and kind of, stretch it out.
Well, I've found myself telling people not to feel bad about science books or math books because they feel like they're not understanding because they can't read them quickly. And I tell them it's slow reading.
That's right.
You think and what these pictures do in your books is naturally slow things down. Yes. And so we can count the teeth on the infinite chicken and things like that.
The infinite chicken.
Right, no, that actually, yeah, I think you really hit the nail on the head. Like, in a way, these pictures are just there to sort of space out the words. I mean, I hope they're, entertaining for people and illustrate the words, but, really it's like, it's just a way of slowing it down. Right, so this is supposed to be a chicken whose teeth kind of go, you're seeing it in perspective. It's supposed to go on forever
and ever. Infinite
yeah,
chicken.
that's right. That was one of my favorite pictures.
But it's hard to get people to read a little bit and mull over, and these pictures help them creatively and in a fun way without even having to stop and think about, oh, I'm supposed to think about this. I don't feel like it right now.
Yeah.
Oh, yeah, definitely. Well, that's one thing I thought about even the kids' books. You just take a little at a time.
Right. That's right. I mean, in the big numbers book, I had a similar idea where it's, in a sense, it's a counting book. So it starts out very slow. And I also, this is actually something I actually thought this was a good, something like this. I think maybe not those pictures, but they should be in a lot of books, which is just that, you don't even have to finish the book, or, when you read it, you can start a book and take something away from it, come back a year later when when you've digested it, or when you have more time, or whatever. So, so this book, it starts out counting 1, 2, 3, like every other counting book, but then eventually it gets into exponential notation and plexes, Googleplex, Googleplex, bigger and bigger numbers like that, and so it sort of, it kind of takes off like a rocket, I guess.
Right, and you even did the beginning, includes your daughters in there, and you're talking about a game of bucking bronco.
Exactly, right. It starts slow, and don't worry. I wanted people. Well, basically, I wanted people to get the book. So I didn't want people to look at the, leaf through the book and get to the end and say, well, I'm never going to understand this.
Right.
Yeah.
I wanted them. It's more like, well, you could get this book for somebody young, and then you could read the beginning of it or some of it, and then maybe as you learned more in school, come back to it and then sort of see the end of it. I mean,
and Joanne's found them non-intimidating.
Oh, well, the kids' books are definitely not intimidating.
Yeah, the kids' books are not. I mean, that's right. But and I've had this as a mathematician. I've had this experience all the time where it'll take it may take me years to understand a concept, and it may be that I've heard someone say something, or in a lecture, or read something, and I just couldn't get my mind around it. And then, like, one day 5 years later, I'll just wake up and say, oh, that's what it was. So, in a way, it's like everything I know about math, I feel like it's easy. Now that what I know, I feel like, yeah, that's pretty, that's straightforward and easy. But it was hard to acquire what I've learned. And so I'm very, as like a working mathematician, I'm very familiar with this idea of, like, having to put stuff away and come back to it, make multiple passes through things, and so I thought that was important to put in a book like this, where I was trying to write a multi-age counting book.
Right. So this. I mean, it starts probably what age? Any age where a kid can think above 1 million or something.
Yeah, a 4 or 5 year old could read the beginning of it, and and then by the end it's sort of hard to say.
So, and I saw your Gallery of the Infinite recommended middle schooler.
Yeah, it's hard to. I mean, I've never liked this. I never liked this question so much, which of course everybody asks us, was like, what's the target age?
Right.
Just as an. I mean, I understand. Certainly from a business perspective. I mean, you want to market your books, and the bookstore has to know where to put it. They have to think a lot about ages. But as a writer, I think I don't think about it in those terms. I mean, for one thing, two people the same age might be at very different intellectual levels and have very different experiences.
That is true.
So age is not everything. And also I think that books can, I mean, I still like the Dr. Seuss books, for example. I'm a middle-aged man.
Right.
I still enjoy.
Yeah, I saw someone referenced you as the mathematical Dr. Seuss.
Oh yeah, I'm not sure where
Very
this
nice.
came from, and I don't. Yeah.
But then these books, I've only looked thoroughly through Gallery of the Infinite. There are different things to read for. I don't see why a young person can't read and make fun of the goofy monsters and count the eyes on the rational crocodile or something. And that means exposure and familiarity, which I think go a long way towards generating interest and getting rid of fear.
Yeah, I think that's right. I mean, I actually wrote a kind of a sequel to Gallery of the Infinite, which I don't think will ever be published, called Life on the Infinite Farm.
Oh, wow.
This book, somehow it got onto Tumblr, where it got thousands of views.
Oh.
But I tried to just take all the animals. So it was about kind of infinite farm animals. So I took all these different animals from the Gallery of the Infinite, and I sort of put them on a farm, an infinite farm, and you know, they had various kinds of problems. Like, you know, I made stories around like why is a chicken wearing braces, and I think the chicken is maybe in the it changed a little bit in the farm book, but I wanted to. I did exactly that. I thought that there would be certain things about the Gallery of the Infinite, like the animals, infinite animals, or infinite people. Maybe this would go well in a children's book. I'm not sure if this thing's ever going to get published, but
I do see it on PDF online. Infinite cow. Gracie is one of the animals.
Right. Yeah. That's right. It's on. That's right. It's on. You know, and it got on. I mean, it had an interesting reaction. I mean, you know, there were thousands of views from Tumblr, and some people loved it, and some people were horrified. You know,
why were they horrified? Do you know?
Well, they thought of it as Lovecraftian, you know, like sort of monsters, infinite. They view these things as monsters, and the children would not want to look at a monster with giant teeth. But I think that people who say that have not been around children.
Right. I was going to say, who's saying that?
I mean, the children, you know, they're afraid of various things, but you know, they might love dinosaurs or. My 3-year-old nephew, he loved. We had this floating crocodile in the pool, and for a while we thought he'd be terrified of this, but he loved it. So I just mean, you know, like the people may look at this as some people probably looked at this as adults, and they thought that these infinite monsters are going to be terrifying, but I don't think so.
It's very fun. I'm just looking at it now. I like it.
Yeah, thanks. Yeah, right. So anyway, that one, who knows if I'll, who knows if I'll eventually get that one published.
So, so that does lead me to the obvious question. So are there other books planned? I see you have other books, but they are definitely not in this vein.
That's right.
Maybe they are, and I haven't opened them, but.
No. The other ones, no, the other, I mean, maybe I've published like 8, 5 others besides these, which are like research monographs.
Okay.
So a lot of my research I'll publish in book form because I don't know. I like writing books. I mean, I like kind of developing the theory, and but these other ones, yeah, you wouldn't want to subject.
Just
much
saying.
more of an acquired taste. I mean, I'm thinking I've sort of started another one, which would be a kid's book about topology, which topology is really, some people call it like rubber sheet mathematics, where it's all about what objects would be like if they were stretchy, and there's the famous example of how a coffee cup is the same as a donut to a mathematician, because you can kind of, if it was sort of made out of some stretchy goo, you could imagine the coffee cup just sort of stretching and deforming until it turned into a donut shape. So I thought a little bit. I was I mean, the impetus for writing kids' book has a little bit gone away, just because my kids are older. So when I was around little kids a lot, I was more inspired to write for them. I'd tell them bedtime stories and all kinds of things. And although this spring I was at the Isaac Newton Institute in Cambridge for part of my sabbatical, and some of the other members there had little kids, and they even had a math circle where some of the mathematicians would come in and explain various kinds of things to the kids. So I did this. I was the teacher about 3 times, and the lessons were all about topology in one way or another. And so it has kind of inspired me to try again.
Interesting. Well,
I might do
would
it.
pick that one up if you. But
yeah, I mean,
so,
no,
so actually, from concept to book, is this what, 7 years or something?
That was a long time. Since then, it's been much, because I mean, that was the first kids book I published.
Right.
And now it's, for one thing, I guess it's easier. I mean, unfortunately, A.K. Peters is no longer a publishing house, but the American Math Society's been interested, and they republished. In fact, they're all 3 of these books now are published with the AMS. So they're happy. They would, I think, like if I wrote another one, I would send it to them, and they would.
Right. Well, because I was wondering, what I mean. Obviously, you're a member of AMS,
sure.
and
that's right.
Just how does this come about that? They would want a prominent mathematician writing popular books, so of course they would want this. But it's pretty. It's not on the cover of these books because this was.
Right.
No, this one has. This one.
Yeah, this one has AMS. Yeah, that's right.
This one is CRC.
That's right. That was kind of CRC Press. It took over A.K. Peters.
Okay.
It was the first book had a kind of complicated story. Then the AMS, CRC didn't. I mean, they weren't doing that much with the book, and once AMS published Big Numbers, they thought to acquire the Monsters book from CRC, which they did.
Good. That's good. Yeah.
So it's all just to have them. The AMS. I mean, they do all kinds of things. They have outreach. I mean, they have they publish some books that describe these math circles. They have some number of popular books about math. I mean, they're very diversified. So I think they just view this as kind of one more direction they might go in.
Right. No, it's amazing. And our library actually had several copies.
Right.
So of both of the 2 books. Actually, I didn't see this in the same area, but it could be somewhere else in the library. These 2 were definitely in the juvenile.
Right. Yeah, that's
and this one could have been there, but maybe someone.
Yeah, it's hard to say. I haven't. It's been out maybe a little less than a year. So yeah. I don't really know what came of it. I mean, it's not quite a children's book.
Right.
And then it's not. I don't know. It's maybe its own category of book or something. Maybe popular math or something. But it's. I'm not sure what it is. So I don't know what kind of reception it's going to get in the long run. The other thing I want to say about the AMS is that they're in Providence. So I basically I can, it's very convenient for me just to go there and talk to them.
Right.
What does your experience say, Joanne and Rich, about how kids come to math? Where do they start? How do they get into it? Because I'm really seeing the importance of the pictures and the multiple entry points, the multiple things.
I mean, yeah, that's a hard thing to. I don't know. Do you want to go first, Joanne?
No, I'll let you go first because I'm trying to think. What did my kids do?
Yeah.
Everyone. They're forced to take it in school. I mean, it's one of the kind of core subjects that just sort of stays with you for better or for worse.
Right.
All throughout school. I mean, I sort of, of course, there's some great high school teachers and middle school teachers. I mean, there's some great teachers, but I would say for the most part that the people who end up going into math kind of do it in spite of their early education. I mean, again, sometimes it's wonderful, and I've known some my kids have had some great teachers going through, but sometimes it's not. And I remember my own experience was pretty bad. I mean, I loved math, and but in school it was just something that I felt like I just have to get through this class as fast as I can. And it wasn't until I started I started reading kind of math books on my own in high school, and that was really what got me. So I don't know. I mean, there's one way is through the schools, and sometimes there's math clubs. A lot of the schools have clubs or teams, or there's now also computer programming, which is in a sense close to math. So anyway, so through extracurriculars, there's also these math circles where there are these, like, for example, there's a Berkeley math circle, which is a famous one, where some professional mathematicians in the area will have these really kind of high level math teaching sessions where maybe I think to some extent it's modeled on it's like a Russian style model. In Moscow, there's a famous schools where they would start kids off very young and get them interested in math. So there's some, the mathematics community makes some outreach effort these days. So some kids get sucked in like that. There's Olympiads, there's some people who are really, really great problem solvers will, do these kind of ASHME and AIME and IMO, and they'll get into math through competition.
Right. I think, believe it or not, I sort of got roped into helping grade for one of those math competitions, believe it or not, because the kid's dad's father, so my father-in-law he's an engineer, but he was involved and then said, we need some graders. And so Bob and I both go along. I'm like, give me the easy stuff. I had to just take if that's the answer, yes or no. And that's all I could do. Yeah, I remember this because there's just room full of kids like doing problems. Yeah.
I mean, it has, I don't know. I mean, I prefer a more free form and kind of non-competitive approach more, but I mean, some people love these competitions and they're talented. They might as well do it.
That's true.
Yeah. So it's a mix. There's, I've done. One time on my sabbatical, I tried to teach like I go once a week to the middle school and try to have a little math club for 6 or 7 kids, and so there's occasional things like that I've done myself. I tend to do things that are whatever age my children are. I will.
Yeah. No, that's very very common. Very common.
Yeah.
Maybe what I'm really wondering about is math anxiety is what we used to call it. It seems such a problem. I want to know if that's learned or whether that is an ability that kids come with, or a disability that kids come with. That's that's learned, and then the question always is, how can you avoid that, or how is it learned? I'm thinking about your pictures, which are fun and non-threatening and have sort of the math built in, and say to kids and their parents, look at these, count the teeth.
Right.
Well, and I'll give my personal experience. So for me, up and through till high school, math was fine. I didn't fret about it. I didn't, I wouldn't say I loved it, but I was like, I liked being successful at math. And then I get to high school, had a difficult teacher for algebra. And my parents were both just enough educated, right? So they didn't get to do algebra and they didn't get to do whatever. So I had no support. There's no internet back then. There's no clubs. There's no, so I was sort of left with this teacher that I felt I could not go to get explanations. She wasn't explaining it well in the first place,
Algebra
so
seems a hurdle for some people.
Right.
Yeah, and in and of itself, like now I look at it and I go, oh yeah, I still remember that. But now geometry for me, but I've noticed there's a trend. If you like geometry and you like statistics, then you probably don't like algebra and calculus. I've seen that over and over. That's me.
I see. That's funny. Yeah.
So calculus, or not calculus, stats and geometry were great for me. No problem. But algebra, calculus, and just enough
to
make
it could have been again like function of the teacher and or the environment.
Yeah, exactly. So that was for me, was this environment that my parents wanted to help, but they, we don't have the resources. They didn't have the knowledge, so.
Sure. No, I think having a good teacher. I mean, I had this experience with history, learning history in high school, where I it was sort of a series of facts. You know, it was very dry, and we were supposed to learn about the dates of the Lewis and Clark expedition and so on. And like then when I got to graduate school, I remember having a friend who was a a history graduate student, and he was talking about all kinds of fascinating things, like were people bored in the 17th century or the Middle Ages? Like, was boredom a concept? I remember that they were studying all kinds of interesting things that that wasn't just the Lewis and Clark expedition or something, or the signing of the Declaration of Independence. So I kind of I don't think I would have become a historian, but I I remember seeing, this is actually a fascinating subject, or could be.
There are actually ideas and stories involved, and stories are
right.
great.
That's right. There's themes, ideas. So math is like this too. I think where does math? It's hard to say where math anxiety comes from. I mean, it's in the air, so it's communicated from one person to another, and it might be even communicated from teacher to student. Like the teacher may have the attitude like, well, look, this is just a bunch of hard, complicated stuff, and we just have to get through it because there's an exam at the end.
Yeah. Right.
The infinite chicken makes it a story.
Right. I think it's important. You can make it a story. You can try to. I don't want to say relate it to real world things, because I think it's a mistake. Math is its own thing, and I don't think it's always good to try to relate it to something real world. But I think you can relate it to things that people already know.
Right.
Like, let's say, how to tie your shoes is a procedural thing that involves, kind of moving kind of arcs around in space, and and you could imagine some parts of some geometrical parts of math or procedural things being related to that. Let's say, or there's lots of things that people do well. I mean, watching various kinds of animations. People love animations, and everyone loves symmetry and kaleidoscopes. And there are things that you can. I mean, this is how I learn new math. I try to relate. I have some small bag of things that I know well, and then whatever the new thing is, I try to fit it to what I already know. And
well, when I was in high school, relevance was a big deal, and I sort of discount it. And it may look the same,
wait,
but
I missed what you said. What was a big deal?
When I was in high school, relevance.
Relevance.
Was,
I see. Yeah.
About it all the time for some reason. I don't think it was really terribly important. I think the storytelling is important, and in Gallery of the Infinite, and now I'm seeing these other books, I think that it's not so much that you can relate to the chicken or the creatures. I still think it's the invitation to play that is going to work for kids who are less than teenagers, and maybe even older, who may have gotten out of the habit of playing to learn, but can be drawn back into it. And that's going to work for adults too, who really out of there.
Yeah, I'd sort of pictured that, like, people, let's say lawyers or doctors might like this book. You say that they're intelligent people who might wonder about things like this, but not have a source immediately available.
They'll probably love it as long as no one sees them reading it.
Right. Yeah, you can have a kind of a more serious cover.
Friends say, no, really, you should read this because it's a lot of fun and you'll learn stuff. And I think fun is.
Yeah, that's right. I think that's right. A lot of, I mean, maybe about science in general. It's kind of play for adults.
Yeah. Definitely.
A very intelligent, creative 10-year-old, maybe she was 9 at the time, when I was teaching her beginning cello. And what was most successful with her, and then I've seen it once I've noticed it, is not to discourage or avoid her sense of play. She loved games for whatever reason and things. So you indulge in the games, it becomes part of the whole experience, and learning is fun, and you actually learn.
Right.
I think that was valuable, and I see that in this, and I still think it's valuable.
Right. Oh, and actually, I have to say, so I came back around with math and calculus when I started to take college level physics, because we're required to as biologists, and suddenly I went, that's what it's for. So for me, it had to be relevant. Like,
it was related, relatable.
Yeah.
To,
so it would be very difficult for me to love math for math's sake, but that it did finally click, and I went, okay. And now I can do math if I know I'm getting to the end of something that's important to what I need to do.
Oh
right?
yeah, that's right. I mean, that's right. There's that whole other side of math where it's, in fact, it's useful.
Right,
it's like,
right. Or you want to
extremely useful.
explain magnification versus resolution, and then you go, look at the formulas for the two. They don't overlap. So you can magnify something and the resolution is not going to increase. But like for me, this was like, oh, look, oh, that's why it doesn't work, because the mathematical equations don't work together, right? So, you know, those...
I have my own theories about how we assimilate physics, but this is hardly the place. And my battery, if my battery runs out, I may disappear. But
well, actually, this is a good time then with 3 minutes left. Richard, is there something we didn't ask you that you would like to answer? Ask yourself an answer.
Oh, well, I wanted to say a little bit more about the pictures because I didn't quite fully answer that.
Yeah.
So I mentioned this program called Xfig, which is a kind of a fairly, it's a good but kind of primitive drawing program. So the program I used for the really big numbers and for the Gallery of the Infinite is a program called Inkscape. So maybe just a shout out for Inkscape. I mean, I love Inkscape. It's, you know, it's free. I mean, it's just kind of open.
Oh wow! And you just mouse over and
yeah, you can draw, right, straight lines, and it's much more. I mean, it's a little bit like this Adobe Illustrator program. I mean, maybe a little bit simpler, but you can really micromanage your drawings. So I mean, you can draw a straight line, you can drag it out, you can move control points, tangent lines, and make the curve wiggle as you like. You can shade the colors in all kinds of ways, and you can really move things by kind of micrometers. And so I just love this program, and I mean, it's I never felt like I was naturally talented at drawing. I just feel like I'm a good reviser. So, I'll draw something and then I'll look at it, or maybe my wife or my daughters will look at it and say, no, that's not really right. The eyes are too big. Then I can go back and adjust. And, after a while, I can get a pretty good picture. So these pictures are kind of very, very heavily revised, I'd say. I mean, they're kind of, I mean, it doesn't come, the drawing doesn't really come naturally to me at all, but I just, I can have a lot of control.
I was wondering if when you were a kid, these were the kind of things you would draw, right? Or
no, I didn't. I had this funny, when I was a kid, art is another subject where I felt like I didn't have such good teaching, I had this idea that like landscape drawing was really the height of artistic creation. And I always thought, well, I can't draw landscapes, but then then somehow eventually I realized I was better with these kind of brightly colored computer drawings. So I have a more sophisticated view of art now. It doesn't just have to be one thing.
Well, it's very effective.
Oh, thanks. Yeah. So anyway, that was really I wanted to say that about the drawing.
Okay, Inkscape. So
Inkscape,
Jeff will make sure to put this under like the YouTube video,
or something. Yeah. I think in the back of the books I say that.
Okay.
The Inkscape drawings.
You give them a shout out. That's great. That's great. Well, Jeff, anything else right now? We're at the top of the hour.
No, I have a thin red line on my battery, so it's worked out really well.
All right. Well, anyway, thanks so much. It was a lot of fun.
Yeah,
I love the books. I'm glad we can point them out to people and talk about them, and I think I like them even better now.
Oh, no, they're fantastic. So Gallery of the Infinite, really big numbers, I should say, and you can count on monsters. So yeah, if you've got kids in your life or you're just interested, then go ahead and pick them up. Richard, it's been a great pleasure to meet you and to actually have our first mathematician on the show. So all right, everybody, thank you for tuning in, and we'll see you again next time on Read Science.
Okay.